In this video, we will be looking at how to implement ZImageTurbo locally in Python. It was released by the Tongye Mai group, and the model is only 6 billion parameters, which allows it to run on most consumer graphics cards. In the first half of the video, I will implement their demonstration, and in the second half of the video, I will add some additions to increase its functionality. To start off, I have a blank project workspace, and I'm starting completely from scratch. So first I'm going to create a virtual environment, and we'll create our model file. And now I will activate my virtual environment. So first, to get some of the dependencies out of the way, we do need diffusers, but currently diffusers is not updated with the ZImage pipeline, so we have to install it from the source. So we could copy this right here. I'm using UV, which if you're not using UV, just remove this keyword and do pip install only. So now we will install diffusers from the source. We will also need to install transformers. And finally, we will also need to install PyTorch compiled with CUDA if you have an NVIDIA graphics card. To download PyTorch, you could go to pytorch.org, and below you will select which CUDA version you have, and it will give you the correct install. If you need to find out what CUDA version you have, you could type NVIDIA-SMI, and this will pop up, and I could see I have CUDA version 12.9. In testing this, I have determined that 12.8 will work fine. So you could just copy this, we will not need torch vision for this, so you could delete that. And then hit install. Now I will go back to their Hugging Face page, and if we scroll down, we can see the example code. So I will just copy this and paste it into our model file. And so here we create the pipe. We send the pipe to CUDA, and that will make the generation faster. And just for testing purposes, I will leave the default prompt that they kept. And right here, we use the pipe object to create the image. And as you can see, we have the height, width, the number of steps that you take. They recommend 9 steps. We have the guidance scale, and since it's a turbo model, we actually don't have to worry about the guidance scale much, but once the base model is released, then that will have more of a factor. And here we have the seed. The seed essentially controls the randomness of the image. So if you use the same seed for the same prompt, you will get identical images. But if you use the prompt and then randomize the seed, the image will change. It will still adhere to the prompt, but it will just be a different image. So you can use the seed to keep the likeliness of an image or change it more if you desire more randomness to it. And then once our image is generated, we just save it to example.png. Now with the code implemented, we will run the file. The first time you run this, it will install the model from Hugging Face. Since I've already installed the model, it will skip that step and it will just load the checkpoint. So now that the checkpoint is loaded, we can see it's generating the image. As we can see, it took roughly 10 seconds to generate, and we could check our output in the sidebar. So here is our image that they provided the prompt for. Now to make this a bit more functional, I'll create a new file. Just model v2, doesn't matter. And we will turn this into a function. And I have to add the imports into this file as well. So when we call this function, it will return the pipe object. And then we will also create a dedicated function to create an image. So we'll take the pipeline as the argument. We'll pass the string, number of steps, which again they recommend 9. And then we'll also make arguments for the width and the height. The CFG, which we could just set to 0 because again it is a turbo model, and the seed will equal none. And I actually forgot an argument. We want to include the output path. And we'll go back over here. We'll take this bit of code and paste it within this function. Instead of saving it to example.png, we'll save it to output path. The guiding scale will be equal to CFG. The inference steps will be equal to steps. Width equal to width. You get the idea. And then we'll set that equal to seed. Now we will say if seed is none, seed equals, and then this torch.generator function. So this way we get some control over our image with the seed here. And then this is our create image function complete, and up here is the create pipeline function. Also, if you are struggling with VRAM, another tip is you could do pipe dot model CPU offload sequential. Really, you could do a few of the different CPU offloads. You could experiment with whatever works best for you. Now, it will take forever if we want to do multiple prompts and we have to load the pipeline fresh each time. So, I will now create some code down here, if I could type correctly. Where we will create the pipeline. And then we will do our create image function, pass the pipeline, pass the prompt, and the output path. Now, we don't have these variables yet. There are many different ways to do this. Just one example I'll show here is we'll create a file called prompts.txt. And I've prepared just some random prompts to paste in here. Definitely not the best prompts. And you could be really descriptive with this model. So you could, it does very well with adhering to the prompts. So they could definitely be much more detailed than this. And then finally, we will create a function called load prompts. Prompt file string. It will return a list. Believe the encoding is UTF-8. And then, so we're going to read the file, and then we're going to split it into based off of the new line character. Now, we don't see the new line character, but that's how the lines are separated in this text file. So each line here will be its own index in a list. So now we could do prompts equals load prompts. We pass the path where our prompts.txt is, which is just locally here. And then we could iterate through the list for p in prompts. And we'll create an index to help track our output, our file output names. So here we could say file name equals example underscore index dot png. Make this an f string. Alright, so now we can take our list of prompts in the prompts.txt file. We iterate it through it in this list. And then the index will increment. So for our first prompt, we'll get example 0.png, since technically the index starts at 0. And then the next image will be example 1, example 2, etc. The advantage of doing this is, in our previous file, if we wanted to generate another image, we would change the prompt and then run the file again. But we would have to load the pipeline each time we ran the file, and that is inefficient. So here, we create the pipeline, and then we use that same pipeline object to create each prompt. And that should save us a lot of time. So now I will run this file. And if my computer doesn't crash, we will see how long this takes. Well, my computer didn't get a chance to crash because I forgot to return this pipe object. And if we want to be really specific, we could say returns z image pipeline, but that isn't necessary. Alright, now I will run the file. I had to pause my recording because my computer was struggling to generate the images while it was recording. But anyways, we could see that 5 images were generated, which is good because we had 5 prompts in our text file. And each image took in the range of 9 to 10 seconds. So this model is very fast, and as we will hopefully see, its quality is also pretty good for the parameter size. So our first prompt was a man riding a skateboard down a steep hill. I would say that turned out alright. I definitely could have prompted it better to get more details, but it got the general concept. Our second prompt was a dog in a park. That turned out very good. This model seems to excel a lot in realism, which I like a lot. Here's our cityscape. Here's the cars and traffic. The direction of the cars is slightly questionable, but I'm sure you could fix that with better prompting. I gave it the bare minimum prompts, and you know, all things considered, the model still did give us exactly what we wanted, so it wasn't the model's fault, it was more of my lack of a detailed prompt on this one. But yeah, so that still turned out good. Turned out realistic. I would say the image quality is pretty realistic. I'm sure if you looked hard enough there would be flaws, but. And our last prompt was a cat laying by a glass door with the sun shining down. And again, this one turned out very good, I would say. It did good with the lighting, did really good with the fur texture, and yeah, so I'm liking this model a lot. I like the realism that it has, and hopefully this code helped you get started. There's definitely a lot more you can add to it. This is just a starting point to kind of show you how to do things. I will probably make more videos once they release the Z-Image base model, which is the full model, and the Z-Image edit model, which is supposed to be like Quen Image Edit. And if there's any interest, I could also make a video on how to apply LoRa's to this local generation. But anyways, I hope the video is helpful.